Kia ora. We're going to explore the simulation by PhET, the pH scale, and we'll be looking at my solution. Now there's a few things you can look at. We're going to tick this so you can get a visual picture of the hydronium and hydroxide ions. And the first thing I want you to look at is the relationship between these two and the equilibrium constant for water, Kw. So if I have a neutral pH, then I have equal amounts of hydronium and hydroxide ions, and at 25 degrees the pH will be 7, and I will have 1.0 times 10 to the minus 7 hydronium ions, and the same for hydroxide ions. And you can work out the Kw to check that value by going 1.0 exponential 7 minus and multiply it by 1.0 exponential 7 minus, and you'll get the value for the equilibrium constant for water, 1.0 times 10 to the minus 14. So that's the first thing. See what happens when I increase the hydronium ion concentration. And notice this is a log scale, so we don't seem to have increased it a lot, but you can see there's a lot more acid here than there is base. But as I increase my acid, my base decreases by the same amount. So you practice multiplying these two figures together, and do you still get around 1.0 times 10 to the minus 14, because it should equal to the Kw value of water. The second thing I want you to use a simulation for is to practice calculating pH by using any given hydronium ion concentration, and then the reverse where you get given the user pH to calculate either the hydronium or the hydroxide ion concentration. So let's start with this one, and we'll look at how to calculate the pH. So remember, the pH formula is pH is equal to the negative log of the hydrogen ion concentration. So you would say 3.5 exponential 5 negative, and you take the log value of that. And because the formula says it's a negative log, we remove that minus sign by multiplying by a negative. And we get 4.455, etc. And notice we need to not write all these figures in. We just do it to 2 decimal places, so it is 4.45. Ideally, it should really go 4.6 because 5, any number 5 and higher gets rounded up. So practice by taking any hydrogen ion concentration, calculating the pH, and you can check whether you've got the right answer by comparing it with this value over here. Then you can do the reverse, so you can use the pH. So if I clear this, and remember, if pH is equal to the negative log of the hydrogen ion concentration, then the hydrogen ion concentration is the negative value of the pH raised to the power of 10. So I can just say 2.07 negative and raise it for the power of 10. And notice my values over here. It's quite difficult to see it like this. So if I just press that FE button, you'll see I've got a value of 8.51 times 10 to the minus 3. And that is what you would expect here. Now, this only gives it to 2 significant figures. In the exam, give your concentrations to 3 significant figures and give your pH to 2 decimal places. Now you can do the same thing by calculating the OH concentration from the pH and its reverse. You've just got to go through that extra step of first converting to the hydronium ion concentration and then to the hydroxide, or the other way around. Those methods are given in the module. So all the best. Kia ora.